Okay, so today I'm going to show you, it's really only one new thing and it's really not that difficult. It just takes a little while to get the hang of it. And we're going to talk about for the next couple of days vectors, vector addition, and how you work with them. We should remember from yesterday, let's see if we do, or if we need to flip back in our notes. A vector versus a scalar. Write down what you can about those under those two headings. See what you can remember. See what you can remember without flipping back. Is that nothing? Or is that something? Can anybody remember anything about vectors? Yeah. Okay, they have a tail. They have a tip. What's the tail tell me? What is the what? Oh, the tip tells me direction. And what were you going to say, Kira? How much? Yes, it tells me the magnitude. Good. How much to how big, whatever. What was our one example that we got yesterday for a vector? We only got one. If you don't remember, flip back and find it. Do you find this word? Displacement? Yeah? Displacement is distance with direction. So then let's look at the opposite side. How are a vector and a scalar different? What's a scalar have? Yep. So over here we only have magnitude. And what was our, I almost said it. What was our example yesterday for that? What? Nope. It's part of this definition. It's just distance. So over here, I'm going to move back over for a second. I would say like, since we're in displacement, I would say like 11 kilometers, 60 degrees. Over here, I would just say 11 kilometers. So I'm going to draw something on here. I want you to put it in your notes. Yours doesn't have to be as large as mine. I'm just doing that so hopefully you can see it. This was a little too long, but that's okay. Then I'm going to come back through and I'm going to put arrows on these. So, do you guys know your directional degree readings? I don't know if you do or not. If I said northeast, would you know what degree reading that is? No one wants to look at me. I'm taking that as a no. Here? Oh, you're just like doing this. Yes, I want to know the degrees though that go with northeast. Yeah, that's right. Yay, Carter! So this is 45 degrees. This is 0. Good. So the next one's 90. You can add. What's this one? 135. Thank you, Ethan. We should all know this one. 180. Moving right along. Ooh. 225. All we're doing is adding 45 degrees. 270 degrees and 315 degrees. So degree-wise, those are my readings. Now, we're going to go back through and we're going to write in our actual directions. One of the things you one of the things we really do have to pay attention to when we write these things, and it's the same way with the metric prefixes, capitals and lowercase. In both classes yesterday, when I graded the quizzes last night, I had more than one person who didn't follow the rules for capital and lowercase. Chances are, you may have gotten something else wrong, but chances are if you missed some things, that was one of the things you missed. And I have those, I think I put them in the bin for you guys. If we have time, we'll get them out. But anyhow, pay attention to those things. Oftentimes in books, you'll see it done incorrectly. But the correct way to write a directional degree with its label is for the label to be lowercase. So I would call this north, northeast. Oh crap, no I wouldn't. Sorry, Avery. Ooh, this should be east. This is north. People stop me when I do things like that. What do I call this one? Good. Northwest. West. Now I'm down here. What would this be? Southwest. South. And southeast. Now look at the paper that I had you pick up today, not the graph paper. This is just from a little book, an entire book about vectors. If you ever want to borrow it to read it, I have it here at school. Nobody wants to take me up on that. Look at that paper I gave you today. Somebody wrote a whole book about vectors, and what did they do? Look at it. Find the mistake. They did it wrong. They used capital letters. Why do we use lowercase? Because in physics, a capital N equals something called newtons. After Isaac Newton, it's a force measurement. So there's one on there. I should have brought one. Oh, I do have one. Look at, gosh, where is it? Look at letter K with me. That's one you guys have to do. It says 150 capital N 270 degrees. What that's really saying, it's not 150 north 270 degrees, it's 150 newtons at 270 degrees. So that means I'm down here. I'm not up here. So don't let that confuse you. Okay, we got him? Yesterday we also talked about how this is my vector, this is my direction, and this part right here was my magnitude. We talked about that, I remember. So I'm going to show you, like if I were to want to draw one of these, you guys will do it on graph paper. Graph paper is really hard to see under this light. So I'm just going to take, and I'm just going to draw a straight line across, as straight as I can. And then I'm going to randomly draw a vector. I'll make it be right here. So when you get something that looks like that, and you're asked, you're probably going to be given a scale somewhere that says like 1 centimeter equals, I'm just making something up here, 4 meters per second. And you might be questioned about what is the magnitude, what is the direction. So the first thing I usually do is find my direction. And to do that, you're going to take your, so just draw yourself some random arrow that looks like mine. I'm going to take my protractor and I'm going to place it on the hash mark where the little holes are. You guys know how to use these, right? And I'm going to follow my arrow up. And when I read that, I'm just right about at, mine looks like about 65 degrees. I'm going to put that up there. The way that you correctly write in your degree reading, we always move counterclockwise, so I start at the beginning of my arrow and I move this direction. And right here I would write 65 degrees. And then if I had a ruler, I would take my ruler and I would measure it. And when I measure this, I'm going to move it down for a second. Well, how did I do that? Mine measures at 6.50 centimeters. I don't know what yours measures at. Now I have to use my scale, which reminds me we need to fix something from yesterday when we get done. Now I have to use my scale, and I know that 1 centimeter equals 4 meters per second. So I would take my 6.50 centimeters times 4. Which gives me 26 meters per second. Once you get your value, your actual magnitude based on the scale, you write it in 26 meters per second. 26.0 meters per second. That's a little hard to read. So now I have both the magnitude and the direction. There could be an instance where you're given this in the scale and you have to convert it. Like, you need to be able to work with this in all different ways. It's not that hard. So now I'm going to give you one to try. Am I good to move this paper? Let's try, we'll use this scale. 1 centimeter equals 2 kilometers. Oh my goodness. Yep, there you go. 1 centimeter, 2 kilometers. Your vector is going to be moving at 80 degrees. And its magnitude will be 10.5 kilometers. So you're 10.5 kilometers at 80 degrees. I'll write it again so it's easier. 10.5 kilometers, 80 degrees. Try that. So this time when I use my scale, it's going to be different than last time. I'm going to be dividing instead of multiplying because the way we're doing it, the way the scale is set. Raise your hand if you sort of think you know what you're doing. Raise your hand if you would like to see me work through this. Okay. I'm going to let you try and then we'll work through it. And if you don't know what to do, just wait. And I'll let these guys finish up. Okay, so I'm going to lay my protractor on the line, and I'm going to mark my 80 degrees up here where I can see it. Or you can mark it down here if you think it's going to be small enough. And then I'm going to stop and I'm going to figure out how long should my line be. I need 10.5 kilometers, and every 1 centimeter equals 2 kilometers. So if I divide through by 2 kilometers per centimeter, then I have 5.25 centimeters that I need to measure out. Is that right, guys? We did it? Okay. So now I'm going to mark this and move this. I'm going to lay my ruler up here to my hash mark, even though I know I'm not going that far. And that way I can line it up. And I'm going to go on my ruler and I'm going to find 5.25, which is really hard to see with this light hanging on it. Right here. I'm going to move up, put the tip on my arrow. I'm going to make my counterclockwise degree reading of 80 degrees, and I'm going to label it 10.5 kilometers. Now you guys who worked through it before I started talking, did yours look like mine? Did we have the same answer, the 5.25? Okay. Okay, so I don't know where I just come back. I was talking about letter K. Look at the paper that I had you pick up today. What I want you to do, you guys are going to do the black ones that are circled. The first thing you need to do as a lab team, because I'm afraid we're going to run out of time, I want you to go through all the black ones and I want you to set your scale. Like in W, I don't know what you're going to say. Maybe you're going to say 1 centimeter equals 10 meters per second squared. So that everybody in your lab group has the same scale for each one. Do that for the front. The scale, I gave you the scale on the back if you look. So set each scale, and then if, I'm sure there will be time left, start drawing. I'll be walking around to help you, and you're going to compare your vectors each time you finish one. Like stop as a group and say, okay, do ours look the same? But first get your scales done in case we run out of time. Questions before you move? Oh, too late. Can we move? Any questions? Okay. Any questions? Yes. Yes, and we didn't get quite as far as I thought we were going to, so yeah. But yeah, you can make each one a different color. I don't care. All right. See you, Avery.